Hey, we finished the discussion today about the would you rather. We completed the table. Make sure you complete that table. Here are the totals. So option C actually gives you over $10 million. When we graphed it, it looks like this. A was a linear function that's horizontal, slope of 0 like hoi. B was linear. It increased, but only by $25,000 each day. But then we have this blue one, which was option C, where it doubled. So that is actually what an exponential function does. Is it starts out, it kind of gradually increases, but then once it starts increasing quickly, it takes off, and that's what the exponential function here did. So you're going to put this in the pocket in your journal, and we are going to start by looking at exponential functions a little further. It says the basic form of exponential functions is f of x equals a times b raised to the x, where a and b are constants. So I want you to write this down so you can see it a little better. A times b raised to the x. These things are being multiplied, but remember order of operations says do exponents first and then you multiply PEMDAS. So b is the base, x is your exponent. So with linear functions, we have like mx plus b, where m and x are multiplied. With exponential, we have x is being raised to some power, which means repeated multiplication with this b. So we are going to use our calculator to find out how a and b are represented in the function and also within the table. So I want you to clear out the memory on your calculator real quick. Second plus 7, 1, 2. And we are going to put this into y equals and then look at our table. So go to y equals, and we are going to put it in 3 times 2 raised, so this is our exponent, the caret top, raised to the x power. We can look at the graph real quick. See how the graph looks? Looks a lot like the option where we doubled the money every time, every day. So it starts out low, it comes up here, and then it just goes up exponentially. So we need to write down what A and B are. So A is the first number, B is the number that has the exponent, it's the base. So A is 3 on this one, B is 2, it's your base. So we're going to use our calculator to look at the table. So to get to the table, see how that's blue? It says table in blue. So the way we get to that option is by hitting second, which is the blue button, graph. Now let's fill in the table. 0, 3, 1, 6, 2, 12, 3, 24, 4, 48. The next part is to find the ratio. You're doing the ratio going from one value to the next. So the way we do that is by dividing. A ratio is like a fraction that's reduced. So I'm going to take 6, the second one, and divide by the 0. So the first, the 1, when x is 1, and y equals 6. We're going to divide by when x is 0, y is 3. So that's 6 divided by 3. So if you need to, put it in the calculator. Divided by 3 is 2. Okay, now do the next one. We're going to take 12 and divide by 6. No. 24 divided by 12. 48 divided by 24. So what the ratio tells you is how you're going from one y value to the next. The y values are doubling. So see, you have 3, you double it, you get 6. Double it, you get 12. Double it, you get 24. Double it, you get 48. So the ratio is actually what is happening to the y values. You're looking at that number. So the way you find it is by dividing the the next one by that other one. So like 6 divided by 3. Don't go the opposite way. Don't go 3 divided by 6. Instead, do 6 divided by 3. All right, I want you to go ahead and do 1 through 6 on here. Just use your calculator, write down your A, B, fill in your table, find your ratio. Then tomorrow we'll finish the rest of it.